There we go. Hello, everybody. Thank you all for joining today. We're going to talk about something that I find very interesting, and that is Windows client privilege escalation. And for those that don't know me, my name is Oddvar, and I work here at TrustedSec at the targeted operations team. And my role there is a red teamer. So that's super interesting and super fun to do. I also do some security research whenever I have time. And I'm also 9-time Microsoft Security MVP awarded. So that's pretty cool. I do a lot of speaking as often as I can. I blog every now and then. So yeah, that's basically me. If you ever heard of the Lullabus project, that is something I started back in the day. So that's probably, if you see my name, that's probably one of the things you can hook onto my name. Sweet. So the agenda today is we are going to just quickly go over some slides, and then I'm gonna, in the end, show some examples on how to escalate privileges. First, we're going to go over the high-level overview, just a little bit theory, and then go over typical enumeration stuff, and then look at some escalation techniques. And as I said, jump into a lab where we are going to live explore some things. So hopefully that will be interesting for everybody. So high-level overview. What is a privilege escalation? This is pretty basic stuff, but it's important to get the basics here. So the principle of privilege escalation is that you are trying to gain higher access rights than you have initially been granted. So a typical example would be going from a standard user to a system user, or I'll get more into that a little later. This is something that we abuse either by changing admin tasks or exploiting actual vulnerabilities in different software. So that is basically the definition. And there's also two different types of escalation. We have vertical, which is what we're going to focus on in this webinar. And that is typical when you go from a low-level privilege user into something that has more privileges. Typical going from user to admin or user to system or something like that. Horizontal escalation is more when you move into a different account that has basically the same privileges as you already had. So not in some cases that might be interesting, but for this webinar, we are focusing primarily on escalation on the Windows client itself, and thereby trying to get access to admin or system. And of course, why is this a critical thing? Well, of course, the main problem here is that it breaks all the trust models and protections you have in place if you're able to go from a standard user into something higher. So that's something we don't want to happen. And of course, if somebody is able to escalate privileges on a system, that of course increases the attack surface that you can abuse after escalation. So for instance, if like you go from a standard user to an admin user, all of a sudden you can basically do whatever you want on the box, like install software, change policies, config, whatever. So that is one of the main reasons that this is a critical thing in my opinion. If we look at the high-level overview from the Windows client perspective, because that's what I'm focused on in this webinar, I'm not going to go over things like Active Directory escalation and stuff like that. I'm merely focusing on the Windows client itself isolated. So because that's what I find most interesting. There's a lot of different escalations techniques that you can use in terms of Active Directory and stuff. But as I said, this is more the Windows client side. In terms of Windows client, there are a few different roles that we kind of have as a standard. So we have the standard users. These are typical users that uses the system. We have service accounts that can do some more stuff. Then we have the administrators, and we have the system accounts, the system account. So to go over each one of these standard users, they have very limited privileges. So that means they cannot install software, or That's not entirely true, but in most cases, they can't install stuff in program files, and they can't install drivers and stuff like that. They can execute stuff. So if an administrator has installed software, the user would normally be able to execute that. They can also modify their own files and folders. So for instance, if you have documents or if you have settings under your profile, you can change those. So everything personal related to that user can be changed by the user itself. And normally the user can use printers and memory sticks and stuff like that. But in terms of the system and privileges, they are very limited, and it's pretty limited what they can do as by default. Service accounts, on the other hand, comes in different flavors. We have the local service account, we have the network service account, we have the local system account, which is also basically system account. It can kind of be both. We also have the trusted installer, which is a different kind of service account. And if you look into the local service account, often referred to as the NT Authority local service, this is one of the built-in accounts. And this is typically used when you set up a service on a Windows client and also servers to minimize the risk of the service. So if somebody compromises that service, it has really limited privileges that you can escalate from. So this is basically just almost like a standard user in some shape, way, or form. And the other thing is that it cannot access network resources, so it can only access local stuff on the host itself it is running on. More details on the link below if you want to read more about the local service account. We also have the network service account. This is also another built-in account. Just like the standard user, it has a minimal set of privileges, but it does have some dangerous ones. The main differentiator is that this account can access network resources, and it connects as the system account. So from like an Active Directory perspective, that would mean that it connects as the computer account itself. And then we have the trusted installer. This is something that came with Windows Vista. This is a built-in account as well. And this account has some really interesting privileges that even the system and administrator doesn't have. And this is primarily used by Windows modules and stuff, and specifically the installer service, and also sometimes for services to protect the service of being manipulated and stuff like that. More details in the link below. I'm going quickly because we have a lot of stuff to cover. Administrators, this is also a built-in group, and as the name implies, is that members of this group can, of course, make system-wide changes that affects everyone on the system. It can add users, it can change permissions, it can even change privileges and stuff like that, and create services, create scheduled tasks, basically do whatever you want to do as an administrator. So normally you would consider, if you have administrator access, that would be considered as almost full access to the host. Lastly, we have the system account, and of course this is the account that has the most privileges on the Windows client itself. This is basically the system itself, and it can do everything on the host itself. Like if it doesn't have the privileges or access, it can basically give itself permissions to do so. So this is the most powerful account. From a high level overview, if you look at the connection between users, groups, permission, privileges, tokens, ACLs, and stuff like that, a great way of showing this is with this image here, where we have the user itself can have permissions or privileges assigned to the user directly. Or if the user is a member of a group, it can also have other permissions and privileges assigned to that group. So inherently, it will get it through the groups. And all this information is when you typically log on to a Windows system, when you log on, it creates tokens. And this token contains all this information. So when you want to use the token or try to access things, the token will be used. So the token will be forwarded and compared to ACLs, access control lists, and the system will check if the token allows the access to, for instance, data or allows to run a program or other stuff like that. So that is the high-level overview of the process. So to sum it all up, the goal with privilege escalation is to go from a low privilege account or group or something into something with higher privileges. That is the overarching goal. All right, let's go into some enumeration stuff. So to enumerate privilege escalation things, there are different tools that you can use. And this is, of course, not all the tools in the world. This is just some of the tools that I use a lot. So basically everything from sysinternals, you will see that over and over again in this webinar. So process monitor, process explorer, access check, strings, all these binaries that you can download from Microsoft are super useful when you are looking into privilege escalation. And of course, using PowerShell, using the Explorer, just file Explorer, just browsing the machine is super useful. Regedit, Notepad can also be useful sometimes. And also looking at the different system MMCs like services or task scheduler or stuff like that. There are a ton of automated tools out there. Just to mention a few of them, you have PowerUp, which is a PowerShell-based tool that can enumerate many of the things I'm going over today. Same with Seatbelt, that's a C# version of PowerUp and a little more extensive. We also have WinPiece, which is also a great tool for looking at privilege escalation things. So a tip from me, one thing that I do a lot, especially when I get a new machine, the first thing I do is I fire up Process Monitor, I go into options, and then I enable boot logging. And then you restart the computer, and then you fire up Process Monitor again, and it will ask you to save the capture file. And this capture file is something I spend a lot of time on, looking at what's happening during the startup of the system. And this is a tip if you're looking for privilege escalations. This is something to look into, see what starts, see what paths it tries to start things from, and stuff like that. So enumeration, things you need to look at or kind of enumerate when you're starting to look at a privilege escalation is, of course, the service itself, because the service can be divided into two parts. The service definition has its own ACLs, access control list, which tells what user is allowed to do what on the service, what user can start, stop, change the config and stuff like that. But you also have the service binaries where the service kind of runs from. So when a service starts, it runs the binary that is defined in the path. So you want to look at ACLs where the binaries are located, because that can sometimes be interesting, especially if you all of a sudden you are a user and you have write permissions there. We'll cover more scenarios a little later in terms of exploiting this, but this is just to go over like the typical things you would kind of gather. So scheduled tasks as well, looking at the tasks itself that is located under system 32 tasks, looking at the ACLs there, and also the binaries, same as the services there. We also have MSI files. That is something that is the recent years has been super, I would say, has generated a lot of CVEs and vulnerabilities. So looking at what sort of MSI files are installed, that's something we'll look at an example a little later. And also look for abnormal places you can change the registry values and keys. Sometimes you will be surprised that you can actually write stuff in the HKLM stuff as a standard user, for instance. So there's stuff there to look at. Other things that I typically look for when I get a box or I do privilege escalation testing is I look for deployment leftovers, because that could tell you interesting information. For instance, local admin access or passwords So typical is unattended XML, if you find that, or maybe they have some custom scripts or logs, log files spread over the system after deployment. Other things could be look at the event log. If they are running admin scripts and PowerShell logging is on, you could most certainly find interesting stuff there. Of course, this is more of a network-based escalation enumeration thing, but it's still interesting. I would also do privileges just to see what privilege I have just by running whoami/priv. So you can see all the privileges. Sometimes this is configured faultily so that the standard user has more privileges than it should by default. There's also some specific registry settings you want to be on the outlook for. So always install elevated. If you find this turned on both in the user and the system hive, that means you can run MSI files as system directly. So this is a super dangerous setting, and I've actually seen this live many times. So that's something you want to keep an eye out for. Also, like auto logon information, if you can find that in the registry, that's of course free passwords and stuff. Other things I look at are auto runs, and of course, if there are any specific configuration files for applications, sometimes they contain interesting information, maybe connection strings and stuff. Again, that's more directed to network exploitation, but still really interesting when you're doing enumeration. So typical misconfigurations when looking at enumeration is finding service binaries in a user writable location. And also, as I said, permissions on the service itself. That's typical, very typical. And also schedule tasks binary located in a writable location that user can write to. And also, again, permissions on the scheduled task. And as I said already, user writable registry keys. That is something that I typically see. And also, I'm not sure if you're familiar with DLL hijacks, but sometimes binaries running a system has this DLL load order, and sometimes you could place DLLs in specific locations that you can write to as a user, and you can get DLLs loaded. I'll show an example of that in the lab afterwards. All right, let's jump into the typical escalation techniques. So when we look at tools that I typically use when I do escalations, is I use a lot of these symbolic link testing tools from James Forshaw. These are super useful, especially there's a tool in there called set uplock. And if you're ever in a situation where you can see in process monitor that you could potentially do something if you could pause the executable for a second, like, and then swap out some files and stuff. You could use the setup lock to lock a process right before that, change the files, and then release the lock. I'll also show a little example on that a little later. There's also create hard link, which is super interesting. So there's a lot of different techniques and tools in that repo that is worth looking at. And again, sysinternal tools, PowerShell scripts, and of course, Windows commands, and Visual Studio as well, because sometimes you actually need to create some code, especially if you're doing DLL hijacks or creating a proof of concept code to exploit something. All right. So the most typical techniques, USC bypasses, not super interesting, but sometimes that is something you need to do in order to get to system. Also misconfigured services. This is something I'll walk through a little later. And scheduled tasks and install Windows installer files. Misconfigured ACLs and folders in general, and also DLL hijacks. There's also named pipes. We have COM objects, we have tokens, we have environment variables abuse. So there's a long list of things that are typical escalation techniques. In this webinar, I'm going to focus on a few. If you want to read more about the typical case about misconfigured services, you can look at the blog post at the bottom there. That's a CV I found a couple of years back. And this is a typical thing I see every now and then, where a service is misconfigured, and you can basically just swap out the binary or change the service itself. Okay, so USC bypasses. So this is probably the least exciting, but for me personally, I think this is a lot of fun. A lot of the known techniques are documented at a project called UACME, So that's totally worth checking out. The typical process when you're looking for USC bypasses is that you try to find all the binaries or processes that auto-elevates, and then you dig more deeply into that binary. So a typical example would be you find a binary that auto-elevates, you copy that into a folder outside of the system32, and then you change the variables just to see if it behaves differently, for instance. That's a typical scenario you would test for. To find auto-elevated binaries, you can use the strings command, as you see on the screen here. It will look for all the exe files. Of course, you need to be at the C level of the drive. And then it will recursively look for all binary files and look for the string auto-elevate true. And typical output of that command would be something like this. So you can see there's a lot of binaries in Windows that auto-elevates. And what that means is that when you double-click those binaries, they will not prompt you for UAC if you're a local admin. It will just elevate automatically. Yes, into the more interesting stuff. So misconfigured services. The most typical thing is, I guess it's less common now than it was like a couple of years back, but unquoted services is like a thing that was pretty common back in the day. I still see it every now and then. And also that in combination with you having write permissions to the folder path where the service is located is normally an easy win. So there's two commands here. Since Vimic is being deprecated in Windows 11, I included also a PowerShell command to list out all the services that is missing quotations. So to explain that a little more in depth, if you look on the left, this is a service that is vulnerable to an attack due to the fact that it's missing quotes. So you can see that there's no starting quote or ending quote, and there's spaces in the path to the binary. I'll show in the next slide why this is important. You see on the right side, this is a correctly configured service where the entire path is in quotation marks. So when you start a service that is misconfigured like this is what happens if you look from the process monitor side of things. So you can see from the top here, services exe is starting looking for HR folder, which is part of HR space software. And then it tries to run hr.exe, doesn't find it. And then it tries to go into HR software/bin, doesn't find anything. And then it looks for software bin.exe, and so on and so forth. So if you have permissions anywhere in this attack path or execution path, you could potentially just place a binary here and it will execute. So normally a user wouldn't have permissions to write files directly to the C drive, but normally under subfolders, depending on how it's set up, of course, but normally if they inherit permissions, the normal standard users would actually have rights to write to that folder. So in this case, if somebody knew about this service, they could place a malicious file called bin.exe under HR software, and that would get executed instead of the program.exe when the service starts. So this is just to show the default ACLs on such a folder, and you can see authenticated users here has modify, read, execute, list, read, and write. So that basically means they can do whatever they want. And this is just another way of showing the exact same thing using access check. You can see here that it also lists for all the different folders and exe files. In this example, you could also just change the binary itself, program.exe. But the interesting part here is the unquoted part of the service. All right. In terms of misconfigured services, to check ACLs, there are different ways of doing this. One is just using icackles and point it to the binary for the service. And the other one is just if it's services that is running under program files and you want to look more broadly into it, you can use access check. The important part here is to change the -u parameter. You can see I'm targeting users here, but it could be beneficial to try other variants as well. There's a lot of different groups and stuff associated with a standard user that is worth checking out. So if you run this in this example here, you can see I run it for users on program files, and it finds that the user actually has read-write to a specific binary that the service is running as, serviceacl.exe. That means you can change the binary. For checking others, I also have a gist. I use this a lot when I test for app blocker things, because normally things under program files and program files x86 are whitelisted. So if you can find a writable location, that is normally a bypass for app blocker. So you can see I'm running for users, everyone, authenticated users, interactive, disorganization, authentication, authority, asserted identity, mandatory label, mandatory level, and also percent username percent. So all these are worth checking for because access check doesn't always check for all these if you enter just a username. So you need to check everything because everything is linked to your user somehow, either through group membership or other default system configuration. So in terms of checking the service itself, we looked at the binaries, but you can also check permissions on the service, the service itself. So you could either go into registry under HKLM system current control set services and then the service name and the security a key. You will find a binary blob, and this is the ACL for that specific service. Then you need to decode that. An easier way of doing it is just using SC, SD show, and then the service name you want to check. And you can also use access check if you want to check a specific service using the -c parameter. Access check would look something like this. If I do access check -c to my customer service ACL, you can see here that the built-in users actually has write permissions to that service object itself. This doesn't mean that you can change the files on disk, but you can change the service configuration. So like you could change where it executes the binary from to something you control instead. Yes, other things, scheduled tasks. This is also super interesting. And this is something I've started to devote more and more time into. What I normally do is that I fire up like the task scheduler as an admin, and then I look at all the tasks manually because I feel that's most fruitful. And on top of that, I also do boot logging and see what sort of tasks that run at startup. Sometimes these are like the tasks cannot always be seen as a default user or a standard user. So it's useful to have like a boot log so you can see what sort of execution that happens during startup. To check the access on the tasks, you can use the access check command that you see here, and also again replace the -u with whatever you want to check. Yeah, so one thing is, of course, the scheduled task, but also, like, as I said, ACLs on any binaries that the scheduled tasks uses. So if you find a task that is running a system and it runs a binary under for instance, the HR software part, where we have write access, that means you have a golden opportunity to become system. So here is just an example of running access check towards the tasks under system 32. And here you can get a list of all the different tasks you have write permission to. Other things, and the most common thing I find is that, as I said, the most common thing I see is at startup, that it runs binaries from an insecure location. I recently had a case where the binary itself was protected, but the folder that the binary was located at was not protected fully. So I could add files to that directory. Turned out that the startup of the system, there was a task that ran that had a binary in this location, and the binary itself was vulnerable to DLL hijacks. So what I could do, I could just place a DLL next to the binary, and I could get code executed as system. That is a typical attack that is super interesting to me. Also, MSI installer files. This is something that is really worth your attention, especially if you have a corporate image with a lot of MSI files. So when you install software, they end up in the C Windows installer folder. And this is the design of the Windows installer service. And there's also some other locations if you install as a user. There's some applications that you can install without running a system. So the command you see at the bottom with the green, with the get WMI object, is a command you can run to list out all the different installed MSI files located in the Windows installer, including the name of the product. And this is super interesting, and we'll look more into that in the lab a little bit. I have a pretty cool example that I haven't fully fleshed out, but I think there's a vulnerability there. So we'll see. I can at least point you in a direction of a possible vulnerability there. So this is how it would look when you run the command. You can see on the left, you can see the name of the different MSI installations, and on the right side, you can see the actual package. So to exploit this, or to check for escalation possibilities here, you would basically fire up Procmon with a filtering of some kind to avoid all the noise. So typically you would focus on MSI exec or things running a system. And then you run MSI exec -fa, which means that the MSI exec will try to repair the installation. And then you need to point to one of these MSI files we found before. And depending on the package, sometimes it requires elevated privileges, sometimes not. Sometimes you can do stuff even though it requires privileged access because it runs stuff before it gets to the USC prompt. So there's interesting stuff there for sure. So what I typically do is when I run this process, I do in Process Monitor, I open up tools under the process tree. And if I see stuff like PowerShell, CMD, or stuff like that spawned under MSI exec, that is definitely something I want to check out, because that means that we could potentially run or get access to a PowerShell window, maybe pause it and break out from it as system. So that is definitely interesting. So yeah, just do process monitor, run MSI exec /fa, and then the different MSI packages, and you'll be surprised to what you find. So as I said, look for conhost, PowerShell, or CMD windows flashing. If you see they like a short pop-up on your screen, that is a good indicator, but also the process tree. Also look for files, what it writes to, reads. If there's folders you can write or read or change, that's very interesting. I would also look for name not found. That's typically if it goes into a folder you have write access to, and it tries to load DLLs. That is interesting because that means you can place a DLL there and you can get code executed through that. If it starts PowerShell, sometimes if they forget to set it up correctly, if they forget to include the no profile option in PowerShell, you could also trick it to load a profile in your folder. Sometimes PowerShell goes into each of the different profile folders, and you can get it to run code that way. Sometimes it just calls other binaries. That is interesting. Set up block is, of course, something you would typically consider here to pause the execution. So let's say you know that it fires PowerShell, and then you can pause it by setting an op block on like a DLL or something that it tries to load. And then you can click on the PowerShell window and maybe do properties on the window and escape from that, and then you have a system shell. There's stuff there that can be done. Let's see. And just to go over a case, this is a finding I documented on a blog a while back. I ran the repair option, and the cool thing here is that as part of the repair process, it actually resetted the ACLs on a bunch of files. So you can see here it does set security file on icls client.log, and it changed that in such a way that everyone got full control. So what I did is that I deleted the file, and then I created a hard link to point somewhere else. So in this instance, I just pointed it to a service binary. So when that process ran as system, it changed the ACLs on the system or in the service binary. And that way I could just replace that binary and run a system. So that is just a typical example. I was going to talk a little bit about my latest discovery, but unfortunately this will not be released until June 10th. But I will be showing an example that is pretty similar in the lab coming right now. So let's jump into some demo. Let's see. So to first explain, this is just a computer, Windows 11, logged in as a standard user, but I have elevated shells as administrator, so I don't have to log on and off the entire time. And let's take a quick look at the first scenario where we have a misconfigured service. So this is a service that we saw in the slides where HR software bin folder program exe. So if we do procmon and we try to start that service, of course I need to do this as system. Normally this happens at startup. So if I start that service, it will ultimately fail. Hopefully soon. I can just close that. And then if we search for program in procmon, we can do like this. So we can filter it out. So you can see it starts program.exe, and if we go to just before that, you can see that it queries the process we saw earlier to try to find HRX, binexe, and stuff like that. So what you would typically do in this scenario as a standard user, you would go in here, and then you would basically just place a file called bin.exe. This file here just creates a text file under the system32 folder. So I thought we would just quickly boot the machine. Or maybe to avoid booting, let's just start the service as admin to save time, because I see that we were already getting at the 40-minute mark here. So this is services running as admin. So let's just go into procmon again. So we can have that running. And then we are starting the service, pretending that we are booting the system. Automatic means that it will run at startup. And then it fails. And if we go here, we should find that bin.exe will get executed someplace down here. Whoops. That was a little too fast here. Oh, let's just filter it. It's faster. Bin.exe. And you can see that it started bin.exe instead of the normal one, and it should be running a system. You can just check that on the far right here, integrity system. And it should create a file under the system32 folder called something something. Let's find it. Find it again. System32. I think it's file from system. There it is. This just got created. You can see 642. So that's like, this just illustrates an example. And of course, normally you would do something more malicious than creating a text file, but it just proves the point of this specific scenario. The other thing I wanted to show was was the scenario where we had a misconfigured service directly. So not the binaries, but like the service itself. So in services, I have pre-created a malicious, well, not a malicious, but a service that is faultily configured. This service here. The thing that is faulty is that normal users has write access to this. So if I do access check, I can see that normal users has actually write access to this. So what you could do from this is that you could basically just, from a normal user, do something like this, where you do scconfig, and then you point the binary path to something else. So if I do, where is it? Customer service. You can see the binary path here points to program file something something. So if I run this, it should change it. You have 5, and then you can see it has changed to the new path. And then you start the service or reboot the machine or whatever you need to do, and it will execute your binary. Yes, let's check out a scheduled task. So I have prepared I did the boot logging for you, so we don't have to do the process of booting and doing all that stuff. So I have a PML file here. Oh, I need to go here first. Open. This is a boot log file after booting. And I'm going to cheat a little bit. I know there's a service or a task that runs, and it runs scp.exe. I can show you that tasks real quick from the admin console. So if I go here, this takes up the task scheduler as an admin. I can't see this as a normal user. So you can see this is just a task I created that, I'll make it a little bigger, that runs as system. And it starts sysinternals scp.exe. And if you look at the procmon dump after booting, you can see that it does a lot of different things. But the interesting part here is to see if we can find a DLL hijack. So if I do name not found and I turn off registry stuff, because that's not interesting in this case, we can see that this file in particular tries to load libcrypto and bcryptDLL from that specific folder that it's running from. I have prepared a DLL. It's not super hard to do, but I basically opened up the bcryptDLL from Windows System 32 and looked at all the exports. And then I created that into a DLL. And I placed this under sysinternals here, called 1bcrypt. So if I rename this to bcrypt.exe and reboot, this file should get executed. And hopefully there will be a file placed here as part of the code. So let's try and do that real quick. Yeah, while it's booting, I can just quickly show the code here. This is just a typical DLL hijack code, where it has all the exports, and then just when something attaches to the DL, I run these create file things. Also, when there's a thread attached, I do this stuff here. Okay, it's done booting. So if we log in, we should hopefully see that that file was created under sysinternals file from system schedule task. And to be sure, I also created one under Windows System 32. Whoa. A little faster. File from system schedule task. So you can see that it works. So that is a way of exploiting vulnerabilities or escalating privileges. One last thing I want to show before we kind of wrap this up is in preparing for this webinar, I looked at MSI files, and I tried to find one that was vulnerable, and that wasn't as easy as I thought. So I got pretty close, and I want to show you something, and you can kind of fill in the blanks if you're interested yourself. Let's see. If I start the terminal here, and you would typically run as I showed you in the PowerPoint, you do this command here to list out all the different MSI files. The one we're going to look at is this bad boy here, windirstat. So I'll copy out this. And then I will start a new command here, and then I will do msixec/fa, and then point it to that file. And I also want to make sure I have procmon running. Reset, okay. And then we start the repair process. And did you see that there's a pop-up of a window there? That's kind of interesting. So if we stop here and we look at the process tree and we scroll down to, where is MSI exec? Here we go. So here's some things going on. It's opening up PowerShell and it's running a system. So that is for sure interesting. So let's see if we can find that process. So let's do PowerShell.exe include. Okay. And if we open up this, we can see that it, if I go, that was the wrong one, this one. We can see that it runs this command here. So let's copy that out. So what happens here? So the MSI installer runs, and then it runs a custom action to fire this PowerShell script. You can see they have correctly configured this as no profile and stuff, so it's kind of hard to exploit this. But I believe if I spend some time on this, I might get something working. So the interesting part that I noticed is that it does remove item. So it goes into each of the user's folders and tries to delete everything related to windirstat. So let's see if we can get that to pause there and see what happens. So if I go here and I go to temp, I have this tool setup block. And if I do this, and let me just go into the app data first and prepare this a little bit. So Windows and then start menu, programs. So I renamed this to 1 just to be prepared for this. Inside here, there's just a file that it's going to try to delete. If I change this to windirstat, and then I do set the op lock to read on that folder, press enter. And then if I run the installer, it pauses the installation. This is as far as I got. I couldn't get access to the PowerShell window, but I just wanted to illustrate that this is the typical flow you would use to kind of find something cool or interesting. From here, I'm not sure yet, but I think there's something here. So that was it. That was my demos. That was my PowerPoints. I'm gonna go into the questions and see if there's something there. Let's see. I'm gonna stop sharing. Let's see. Oh, 9 questions. Let's see. Regarding Procmon, don't you need admin privileges already to be able to? Yes, you need to have admin privileges. So this is something you typically would do to kind of map out the system. So the way I do this when I research for this is that I have an admin account and I have a normal account. So I would typically run Procmon as an admin to look for stuff, and I would run stuff as a user to test things out. In terms of boot logging, yes, you need admin privileges. And live, okay, done. Why does the execute chain not only execute the binary specified? That's just a Windows legacy thing, from what I understand. It's just a search path, and there's a lot of these kind of weird behaviors in Windows in terms of how it does things. The same with DLLs. There's also like a specific chain there. It looks into different paths. If it cannot find it, it will try in different places you have defined as the path to try to run that specific DLL. So I'm not 100% sure why this is, but it's a legacy thing from Windows, I'm pretty sure. doesn't handle the spaces that well. Regarding Procmon, don't you need Iron privilege already to? Yes, we do. You should look for vulnerabilities on a test lab where you have all. Oh, there's somebody that answered it for me. Okay, thank you. Done. Will you post slides? I can post the slides. No problem. Nothing super important here. So yeah, I totally see that getting the links and stuff is kind of hard to do on a webinar. So yeah, I'll make sure to post that out. Just follow my Twitter account and I will post it out there. Thank you. You're welcome. Didn't MSI repair option get fixed? Well, I have seen it still on. Yeah, you might not 100% repaired, I think, but oh, you might be right. Maybe it did get fixed. It's partially awful, at least. What happened now? Lost my screen. So I think it's partially fixed, but I might be wrong, of course. I typically look for vulnerabilities with MSI files and find stuff, so but yeah, I still see them pop up every now and then, so I don't believe it's 100% fixed, but I could be wrong. I noticed that there's a lot of MSI installers on the system. Are you going through all of them manually to check? I do it manually, but you could automate this. Of course, there's different tools out there. MSI search is one. There's tons of tools out there for looking for this stuff. Is this a VM for ants? Oh, was the images too small? I'm sorry about that. I didn't think that the resolution would be a problem. Let's see. Arbitrary file to folder index location deletion technique doesn't seem to work on the latest Windows 24H2 builds anymore, as the system returns is directory error. Yeah, I'm actually looking into that right now. So yeah, I have seen that issue. So I'm curious to figure out what that is about. On modern and recent binaries shipped by Microsoft, the process mitigation redirection trust policy flag has been set. So even if you have arbitrary delete, the process won't follow the symlink. Do you know of any ways to bypass it? Not from the top of my head. Might be a good question for Forsha on Twitter. Let's see. On the last demo, what was the MSI installer you installed? How did you identify it, given there are many online? Did you try them all manually or have heuristics in your parsers to quickly try it? I basically just found a lot of random MSI files online, and then I manually went through a couple of them. So yeah, I didn't have any specific things that I looked for finding binaries. I did try to find vulnerable ones, so I tried to look for old versions of stuff, but yeah, that was the one I found that got the closest to a vulnerable one, at least for the time being. Some services have protection against symbolic link when process mitigation redirects process is used. Yeah, that's the same question as before. I wish we could see some USC passes in action, but thank you. Okay, I can prep that for an upcoming webinar. USC is could be interesting to see. I agree. Thanks for sharing your knowledge. You're welcome. What about escalating from the properties window of a PowerShell window? Is that something that you can program through some sort of DLL? I'm not sure. I think you need to manually click, but I could be wrong. I don't think you can. Maybe you can get a handle to the window and do some stuff. I'm not 100% sure on that. I don't have a definitive answer. I would need to experiment. I believe so. There's probably something possible. Resolution was fine. I set my zoom to original size and I got full resi. I had to scroll with mouse. Ant-Man had skill issues. Okay, thanks. All right, that's it. Thank you all for joining. So this will be up on YouTube, and I will also make sure to post the PowerPoint online after this. So thanks all. Have a good day.